So Tyler notes Pythagorean theorem. We'll take notes for about 10 minutes. Pythagorean theorem. However you want. Yeah, it's not in the note packet. This is just a separate sheet of note paper now. Pythagorean theorem. The law says this. I want to put a little star there. Here's the law. In a right triangle. So look how it starts off. Only right triangles. You know what a right triangle is. So this law only applies to right triangles. In a right triangle, the sum of the legs squared is equal to the hypotenuse squared. I'm going to write that down nice and clearly on your notes. Go ahead and draw a right triangle. And go ahead and label the parts. We already know, right? We already know these parts, but go ahead and write it just for sketch it just for review. Recall the two sides that make up the right angle are called the legs. And the third side that's opposite the right angle is called the hypotenuse. I just abbreviated HYP for hypotenuse for now. We got a leg, and hypotenuse. The theorem says this. The sum of the legs squared. So one leg to the second power, but one leg to the second power plus another leg to the second power is equal to the hypotenuse to the second power. I'll write that down. That's what this law is saying. One leg to the second power. The sum, look at the sum means adding. The sum of the legs squared is equal to the hypotenuse squared. And in common tradition, the legs are usually referred to as side A and side B. Side A and side B. And the hypotenuse is typically referred to as side C for shortcut. So it's sometimes referred to as, instead of legs, we just replace them with A and B. So A squared plus B squared is equal to C squared. On a lot of textbooks in the tradition of mathematics, the legs are always your A and B, and your hypotenuse is always your C. Just a little FYI, I'm going to write that down. Okay, example 1. I'm going to write this one down. I'm going to draw this triangle. Let's solve for x. The cool thing about the Pythagorean theorem is it is foundational to engineering, all types of engineering. The applications for this is endless. Time would fail me to talk about all the applications in the real world of Pythagorean theorem. It's the basis of trigonometry, all engineering, practically all engineering, buildings, mechanical engineering, computer engineering, civil engineering. It's the foundation of all trigonometry. It's amazing. Let's go ahead and solve for x here. Before I solve for x, let's identify what our legs and our hypotenuse are. What is the hypotenuse here? Is it going to be x, 6, or 5? X. Alan, give me an argument for why you say the hypotenuse is x. It's across from the right angle. Beautiful. Beautiful argument. The hypotenuse is always across from the right angle. So here's your right angle. It's always the side that's not touching. It's always opposite the right angle. Some people like to memorize the hypotenuse by saying, look at the right angle. It's always pointed at it. It's like an arrow. You see that right angle like pointing at the hypotenuse? Some people memorize it that way. Some people like to memorize that the hypotenuse is always the longest side of the right triangle. However you prefer, that's optional. Let's do it. So, the two legs then are obviously going to be 6 and 5 because the legs always make up the right angle. Remember we went over that last week on our note packet? So, using the Pythagorean theorem, a squared plus b squared equals c squared, let's go ahead and solve for x. In this case, the legs are 6 and 5. Look what I'm going to do. And x is my c. X is my hypotenuse. Right? So the rest is just isolating x. Always the second power. Always. Okay? All right, let's continue. 6 to the second power. Be careful here. This does not mean 6 times 2. This means 6 times 6. So it's 36. This does not mean 5 times 2. It means 5 times itself. It's 25. 5 times 5. Huh? Right. So 36 plus 25 is 61. Careful now. Watch this. X squared equals 61. Good. I'm glad you mentioned square rooting. Now, the goal of any equation is to isolate x. We have to get x alone. X is not alone. We have the exponent of 2. Now, to get rid of the exponent of 2, someone says square rooting, and that's exactly what you have to do. Remember, in equations like a balance, whatever you do to one side, you got to do the other. So if I'm going to take the square root of the right side, I have to take the square root of the left side also. And it just so happens that square rooting eliminates squaring. Square rooting eliminates it or undoes taking to the second power. So this is gone. All I have is x alone, right? Equals to the square root of 61. So x is equal to the square root of 61. Square root of 61 is not a perfect square. In other words, there's no such number multiplied by itself that becomes 61. So what we're going to have to do is approximate square root of 61. In other words, we'll type it into our calculator, and we'll run it to nearest tenth or hundredth or thousandth, whatever degree of specificity I want you to run it to. This is for now, for our example, let's run the nearest tenth. So when you type square root of 61 in the calculator, I heard someone say, what is it? 7.8, give me the second decimal after the 8. 7.81 is approximately x. Look what I'm going to do. I'm going to change the equal sign to approximate because we're rounding them. We're saying, you know what, the square root of 61 is about 7.81. Let's round the nearest 10th place. I look at the 8 digit, I look to the right of it, it's not 5 or bigger. So this is just going to be 7.8. So x then is approximately 7.8. So this is my approximate answer. I'm going to abbreviate approximate. My exact solution was right here, the square root of 61. Okay. So that means x over here, this hypotenuse is actually about 7.8 units long. Or exactly, if I want to say how long is x exactly? Well, I'd say it's the square root of 61 units long. But in the real world, if I say chop up a piece of wood, if we're in construction, chop up a piece of wood, square root of 61 inches long, you'd be like, what's the square root of 61 inches? Well, I'd say, well, that's the exact amount of inches you need to solve. But that's not real world. That's the exact. We need to approximate square root of 61. So you'd say, okay, Mr. Munguia, do you want me to cut a piece of wood square root of 61 inches? Yeah. Well, I need to approximate because that's not a perfect square. Okay, then chop a piece of wood at 7.8 inches to the nearest tenth. But the exact answer would have been square root of 61. It's just not, we can't chop a piece of wood square root of 61 inches. But that would be the exact answer. So that means we have to approximate in real life with those kinds of solutions. Let's try example 2. Example 2, go and copy this one down. So we have exact answers and approximate answers. That's the moral of the story right now. Exact answers and approximate answers. Here's example 2. All right, someone besides Alan. What's my hypotenuse this time? Anybody? Miss Castro. Oh, right. On this example, all I'm asking is, what side is my hypotenuse? Okay. So you're saying the hypotenuse would be x? Thank you. All right. Someone besides Ellen. Thank you, Ellen. He's all frustrated there. He's like, I'm giving him a phone 911. Miss Lopez. Miss Lopez, you say 14 is the hypotenuse. Can you provide an argument? Because it doesn't make up the right angle. Thank you. Agita, can you provide a different argument? Right, it's the longest side. That's one argument. One moment, give me another argument. Right, it's across from the 90-degree angle. Nice. Okay, so those are different arguments for why 14 is the hypotenuse. So in other words, I know C, A, B, and C. C is 14, and A and B would be 7 and X because remember A and B, the legs, they make up the right angle, right? So here's A and B. So this would be my legs, A and B, and then C would be 14. Got you. Gladly. All right, here we go. A squared plus B squared is C squared. Let's do it. So your legs are your A and B. So let's see, 7 squared plus X squared is 14 squared. Cool. There we go. Let's keep going. 49 plus X squared is help. That's what it is. 196. Thank you, Ms. Buckley. Moving right along. Let's isolate X. Right, we got to get rid of 49. So subtract 49 from both sides. Cool. X squared is 147, I heard. I'm really bad at mental math, forgive me. All right, let's do this. Let's get X by itself now. We have to take the square root of both sides, because that undoes squaring. By to the square, so X then is approximately, let's do this, 12.1, huh? To the nearest tenth, or what's after the 1? Yeah, so it's 12.12. I got the floor here, please. Thank you. Hold up, Castro, go ahead. Right, because I look to the right of the tens place, and it's not 5 or bigger, so the 1 just stays the same. If this 2 was 5 or bigger, then that 1 would become a 2. So X then is approximately 12.1. Okay, so the square root of 147, if you grab a calculator and you hit square root of 147, hit square root button, you'll get 12.12. It becomes an infinite decimal. We call this an irrational number because the decimal never ends. In other words, there's no such number that we know of exactly that multiplies by itself that becomes 147. It's a mysterious number. So that means we have to approximate. Any questions here?